students, this is the key for the worksheet you had to do yesterday, so we're going to do it together. Let's start with number 1. So give 2 examples of energy. So from our notes we learned that our main types of energy are potential energy and kinetic energy. What unit is energy measured in? Energy is measured in joules, right? And we abbreviate that with just a J. Explain the difference between kinetic and potential energy. So I'm going to just kind of make a footnote on this. So remember, kinetic energy means motion. So objects that are in motion have kinetic energy. Potential energy, we think of that P, potential, for position, right? Where is the object located? And potential energy is all about, most of it is about gravity. Right? If the ball is on the ground, it has no potential energy. If it's up high, it has more potential energy. So let's do some examples of these. A frisbee flying through the air. So let's look at some of these keywords here, right? The word flying through the air. So that means motion. So therefore, my type of energy is going to be kinetic. This one was a little tough, especially the word wound. When you wound something, you wind it. So a clock, if you were to wind an old clock on the back with a spring. So it's not moving, but it's a spring, almost like a rubber band. So therefore it has energy of position, so it's potential energy. A boulder sitting on top of a cliff, right? So we can draw a little picture of that. You have a cliff, boulder on top. So the boulder is at the top. It's not moving. So it has potential energy. A dog running, right? The dog is moving, so it's going to be kinetic energy. A pendulum at its lowest point. So again, this might be a word that you're not familiar with, pendulum. So if you have a clock, I'm going to draw a little picture over here for you, right? Here's a clock. Some of the clocks have a pendulum, right? That goes back and forth, swings back and forth. So the pendulum at its lowest point, right, the pendulum swings, it's going to have a high point, and it's going to have a low point when it swings back. So it wants to know when it's at this lowest point. If it's at the lowest point, it has potential energy. Okay, water storage tanks are usually built on towers or placed on hilltops. Why? Right, because the water would have potential energy, right? So if I have a water tower, I'll draw a picture. You've probably seen those. They're full of, well, water, right? They can go down. It can use gravity instead of having to use electricity to move it. It's using potential energy. All right, so let's do our 2 math problems. So remember, kinetic energy is 1/2 mass times velocity squared. Potential energy is mass times gravitational acceleration. Remember, on Earth, it's always 9.8. You're not always going to be given that. You have to memorize that. Whenever you have a potential energy, gravity is always going to be 9.8 if it's on Earth. If we're on another planet, they will give you the gravity, but not always for Earth. So make sure you memorize that. So number 1, a 70-kilogram man is walking at a speed of 2 meters per second. What is his kinetic energy in joules? So let's highlight some of these keywords, right? We should always, in our word problems, go through and find our numbers and our units and any words that we think is going to help us. So we have 70 kilogram. It says that he's walking at a speed, so we know he's in motion. And we know it's 2.0 meters per second. Now the problem tells you that it's kinetic energy. However, if it didn't, you should still know to do kinetic energy because he is walking. So walking means motion. Motion is kinetic energy. So let's take what we know, right? 70 kilograms. We know that that is mass. My pen is stuck. So mass equals 70 kilograms. And I know that it's mass because it's in kilograms. Remember, we talk about knowing your unit is really important. Kilogram is a unit of mass. So I know that that 70 kilograms is mass. 2.0 meters per second. Well, I look at my unit, meters per second. Sorry. And I know that that's velocity. Now it asked me for his kinetic energy, so that means I'm solving for kinetic energy. My equation's at the top. I know kinetic energy is 1/2 mv squared, and now I just plug in. So my m for mass is 70 kilograms, and my v for velocity is 2, and I'm going to square that. And then I just plug it straight into my calculator. If you don't have a scientific calculator, make sure you do the 2 squared first and then multiply by the rest. So when you multiply across, you should get 280.5 joules. A 1,400 kilogram car is moving at a speed of 25 meters per second. How much kinetic energy does the car have? So again, let's highlight a couple things. 1,400 kilogram car, speed of 25 meters per second. And again, the problem is nice and it tells me what I'm solving for, which is kinetic energy. So same thing, we have my mass, 1,400 kilograms. My velocity is 25 meters per second. I'm solving for kinetic energy. I write down my equation, 1/2 mv squared. And I plug it in. So 1/2 the mass, which is 1,400, times my velocity squared. And when I plug that into my calculator, I get 437. Remember we said with energy problems you can get really big numbers. So a big car that's 1,400 kilograms is going to have 400,000 joules of energy, whereas the man walking was only about 280. So the bigger the item, the bigger the energy can be. Don't think you did something wrong just because it's a very large number. Okay, a 60 kilogram person walks from the ground to the roof of a 74.8 meter tall building. How much gravitational potential energy does she have at the top? So again, let's break this down. 60 kilogram person walks from the ground to the roof, so they're standing on the roof, and the building is 74.8 meters. And it's nice, and it tells me gravitational potential energy. All right, so let's break it down. 60 kilograms is mass, 74.8 meters is height, right? Because meters is a unit of height. So I'm solving for gravitational potential energy, right? This is what the two things the problem gives me. I know my equation is mass times gravity times height. I know my mass is 60, and I know my height is 74.8. Now remember when I said that they're not always going to give you gravity. You have to know that because gravity is always the same on Earth. So I know that that G in the middle for gravity, right? Mass times gravity times height is always going to be 9.8. So when you're done, just multiply it straight across. So I get 60 times 9.8 times 74.8, and I get 43,982.4 joules. Okay, number 4, last problem. What is the unit to measure energy? Is joules. Don't worry about that power next to it, right? We're working in joules, joules, joules. We abbreviate that J always on the end of our problems.